In the world of forensic science, trace evidence plays a pivotal role in piecing together the puzzle of a crime scene. Trace evidence refers to small, often microscopic materials that transfer from one location or object to another as a result of physical contact. These tiny clues can provide forensic scientists with valuable links among the suspect, the victim, and the crime scene. Here, we explore the different types of trace evidence most commonly examined in forensic investigations. 1. Hair evidence. Hair is one of the most common forms of trace evidence. Each strand of hair contains a wealth of information such as color, species, human or animal, and even sometimes race or age. The hair can be analyzed to identify DNA within the root or mitochondrial DNA if the root is not present. 2. Fiber evidence. Fibers can originate from clothing, carpets, upholstery, and other fabrics. Identification involves microscopic comparison to determine the fiber type, natural or synthetic, color, and possible manufacturer. Fibers are used to establish connections between people, cars, and locations. 3. Glass evidence. Glass fragments, often found at the scenes of break-ins or car accidents, can be crucial evidence for placing a person at a crime scene. The unique properties such as tint, thickness, texture, and sometimes even manufacturer allow forensic scientists to match glass pieces back to a source. 4. Paint evidence. Paint can be transferred in situations like hit-and-runs or vandalism. Layers of paint can be analyzed microscopically to match a suspect vehicle or tool to a crime scene or an object involved in a crime. 5. Soil evidence. Soil samples are often overlooked but can act as a vital piece of evidence, especially in cases of outdoor crimes. The composition, texture, color, and even chemical makeup of soil samples are compared to link suspects to specific locations. 6. Gunshot residue, GSR, evidence ****. GSR consists of tiny particles from a discharged firearm and can settle on clothing or the skin of a shooter. Collections are typically performed with adhesive tapes and subsequently subjected to tests to find elements like lead or barium that indicate gunshot residues. 7. Pollen and plant evidence. These types of evidence include plant fragments, seeds, or pollen that can aid in identifying where a crime took place or where a body may have been moved. The distinct composition of plant life in varying regions can assist in tying a suspect to a precise geographical location. 8. Building materials evidence. This includes materials like concrete, insulation, or plaster that may adhere to a suspect's clothing or tools during a crime. This evidence can be examined under microscopy to identify and link materials back to a particular location or structure. Each type of trace evidence demands its own specialized handling, collection, and analysis procedures, which require meticulously crafted protocols to avoid contamination. Furthermore, trace evidence does not act in isolation. Rather, it becomes extremely powerful when the various pieces aggregate to create a comprehensive picture of the crime. Forensic scientists employ a combination of traditional microscopy, chemical analysis, and increasingly sophisticated methods like mass spectrometry and advanced imaging techniques to analyze trace evidence. The testimony of trace evidence can be subtle, but when employed correctly, it weaves compelling narratives that help solve even the most elusive criminal cases.